Today, class, we are meeting again, grade 8 natural sciences, term 4 work. We want to talk about objects of the solar system. Objects of the solar system. So as you can see, I have got some nice notes that are going to be forming part of our discussion today. I just want to let you understand that all these are going to be discussed in today's class, which we are going to understand various terminologies and various areas of concern with regards to uh, what we call shooting stars, what else, what we call meteoroids. Also looking at the shape of the solar system and gravity. All these we are going to discuss them right now in this discussion. So please just understand that we would also look at forces of gravity in the solar system that balance in a way and keeping objects in their predictable stable orbits. The stable orbits that we are going to discuss again as we go in in today's work. And obviously, we also gonna look at the the Kuiper belt and the Oort cloud. How do they differ? What's the difference between the two? The Kuiper belt and the Oort cloud. How was it? What actually happens there with regards to this? How do we distinguish them? And also the photographic appearance of them. So as you can see, I'm sure that it is gonna be just a very interesting presentation and sharing of now. So without wasting any time, we want to look at, without wasting any time, we wanna look at this and just quickly understand what do you mean by object of the solar system. So basically, the object of the solar system, it includes the sun, the 8 planets that we mentioned in the previous presentation. We said the moons, the 12 planets, like the Pluto. We identified that Pluto is also part of it, of the 12 planets, the asteroids, the comets and other small bodies. So these celestial bodies are bound to what? To the sun by its gravity. These celestial objects are bound to what? To sun by its gravity, causing them to orbit around it in a system often described as a flat disk. So now, what we want to understand is that we have a star. The sun is a star at the center of the solar system, and also gravity source. We want to look at that as its massive gravitational pull holds all other objects in orbit around it. The planets, we talked about them, are named in order from the sun to the last, and then the orbits, which we identified, also talked about that, and then other objects, which we said that we're gonna look at the moon. These are natural satellites that orbit planets or dwarf planets, and then obviously the asteroids. We told we're gonna look at them. So the sun is the biggest. At the sun is the biggest object that it makes up 99% of the matter in the solar system. Pictures of the solar system do not show the planets at their distance from the sun correctly to scale. So if we can look at the pictures of the solar system, if we can look at the pictures of the solar system, it does not show the planets and their distances from the sun correctly to scale. There is no exact, or we are saying they are not drawn to scale. If otherwise drawn to scale, all the object would not fit on a page. So what we are saying is that given this photograph here, it actually shows a typical appearance of the objects or the typical appearance of the solar system uh, and also uh, the various planets from as they rotate and as they move around the sun. So now what we need to understand is that they are not drawn to scale. they are just a typical representation of them. So, like I said first in the previous presentation, we have our sun, and then we have got our planets, which we said we have got Mercury, we have got Venus, we have got Earth, we have got Mars, and then we have got the asteroid belts, which also have the series here. And then obviously, remember we said that there are some pieces of rocks that also hang in the atmosphere. And then we have got what the Jupiter, which we can say the fifth planet. We have got Saturn, and we have got Uranus, which is number 7. And then finally, we have got Neptune. And then we'll be saying that Pluto does not it does not form part of the planet as a reason of what we just said in the previous presentation, that it has no capacity to clear its orbital pathway, so it cannot be able to define or fit as a what as a planet. And then we've got the Kuiper belt objects, which we are also seeing, which is also shown at this far end there, and then which is also made of the Makemake and also the Eris and so forth. So basically, we also have the comets. These are also going to be discussed. We're going to also look at them and explain what is happening with regards to them as we go through our presentation. So now, that's basically the typical appearance and representation of our planets with their arrangement from the sun. So moons, these are natural satellites. Moons are natural satellites that orbit planets. Moons are natural satellites that orbit planets and dwarf planets. The dwarf planets, we said those are other objects which cannot be classified as planets. So some examples of moons include the Earth's moon. We have got the Earth's moon. The Earth has got its moon, and then moons do not have their own source of light, but they reflect light from the sun. I'm sure we are supposed to understand that when the moon is shining, it doesn't have its own light, but it reflects the light from the sun. A moon always moves around the what? At the same planet. Moons always move. We are saying moon always moves around the same planet, where of course Mercury and Venus have no moon. We need to know that Mercury and Venus, they do not have moon. Earth is one. Earth has got one. So if we say NB are planets that do not have planets without moon, without moon, without moon, we should identify that it is of course that I say that Mercury and Venus, they do not have. We have got Mercury, and also we have got also Venus. They do not have moon. And then obviously, as you can see, Earth has got Earth, Earth is one moon, and also we have got Mars, which also have two. Mars Mars has two. So now, gas giants have many moons. The gas giants have many moons, with certain Jupiter having just over 60 moons each. These are gas giants which have got so many moons of them. And then we have got over 60 of them, for example, with from Saturn and Jupiter. So, what is asteroids and asteroid belt? Asteroids, we identify them. These are small rock objects that orbit the sun. Small rock objects that orbit or that rotate around the sun. They are typically found in the asteroid belts. They are found in the asteroid belt. If you can look here, we have got the asteroid belt here. We have got the asteroid belt, which we identified when we look at the moon here. I'm saying when we look on our planet, we are saying the asteroid belt is actually defined, or it can be seen here, which we can say that it is the what? The asteroid belt. It is the asteroid belt, which we can see there. And then what we need to understand is that these are small rock objects that rotate around the sun and are found in the asteroid belt between Mars and Jupiter, which are found between Mars and Jupiter. I'm sure that we can actually see that this is, I'm saying they are found between what the asteroids are found in the asteroid belt between Mars and what? And Jupiter. Therefore, what is in between is the asteroid belts, which are also small rock objects that also rotate around the sun. As you can see, they do rotate around the sun, which you can see on the picture and photograph that I've attached here. So, they can also be found elsewhere in the solar system. For example, we have the Vesta and the Pallas, where they are found also these asteroids. So that is what you mean by asteroids. And then asteroids are made up of materials that are similar to materials of the terrestrial planets. I remember and refer back to you that we talked about the terrestrial planets, we talked about Earth, we talked about Mars, and then we're saying they are the Earth planets, or I mean land planets, which we are saying that they are also materials that forms or that makes the what that make up the what the asteroids, and however they are too small to be called planets. In any case, they can't be called planets because they are too small, and these asteroids have icon cores just like the core of the earth. They've got icon cores, they've got some icons at the center of them, which of course are similar to which we are saying they are just like the core of the earth. So asteroid belt is a huge area in which hundreds of thousands of rock pieces race around the sun. The thousands asteroid belt, the asteroid belt, as you can see, the asteroid belt The asteroid belt is a huge area in which hundreds of thousands of rock pieces race. They move, they move around the sun, and is the area where asteroids are found. So asteroids, as you can see, we talk about small rock pieces, objects that moves around the sun. So reason why they are found in the asteroid belt is because it is a region or an area which has got hundreds or thousands of rock pieces, which actually has to form or where these asteroids are found. So as you can see, that is one thing that we need to understand, that that is one thing that we should also look at when we look at the structure of objects. We are saying objects of the solar system, objects of the solar system. So we have got examples of the stories here. These are examples, rock particles or rock objects. We are saying these are rock objects that are found. We are saying they are found in the asteroid belt. Asteroid belt, which we say it has got thousands, hundreds and thousands of what? Hundreds of thousands rock pieces. So what happens is that we identify these in what? In the asteroid belt. So we want to look at meteoroids, metals, and also meteorites. So now the meteoroid is a small piece of rock in space. It's a small meteoroid is a small piece of rock in space smaller than the asteroid, which normally come from the what? From the asteroid belt. So when you look at it, we are basically just identifying it with regards to the size. It may sometimes enter the Earth's atmosphere and start to burn up, and it is called the meteor. When it burns up in the what? In the atmosphere, it is therefore called what? The meteor. It is called the meteor. So that is often known as the shooting star. That is often known as the shooting star. It crashes when it crashes in the ground before burning up completely. We call that meteorites. When it crashes, when it crashes in the ground before burning up completely, it is called the meteorites. So the meteorites, we are given an example here. This is an example of the meteorites. This is we are in the example of the shooting star. This is an example, e.g., we are talking about what? The the shooting star. The shooting star, which we are supposed to understand that we are looking at as a small piece, what call a small piece of rock space in the space that are smaller than the asteroid, and then comes from the asteroid belt, which actually can enter into the atmosphere and start to burn, and then we call that the meteor, and then which also called the what? The shooting star. So this can also be known as what? The meteor, the shooting star. You can really see that is a shooting star. We have seen is sometimes when you go out during the night, we see some spikes of like uh like the diagram is illustrating here, which identifies that this sometimes we don't know about we don't know normally what's happening there, but now we are saying this has to do with the objects in the space that are also smaller than asteroids, which sometimes can burn up in the atmosphere, and then when they burn up there, we define them what as a shooting star, and then if it actually crashes in when it crashes in the ground before it burns up, it can go until it reaches to the ground before it is before it finishes burning up. So therefore, we call that what? A meteor. You understand? So, I mean, we call it a matrix. So now that is it. So we have seen this, and I want you to relate. And next time when you see this one, you should be able to tell that this is called a shooting star or a meteor. It's a shooting star, which is also called a meteor. If it crashes into the ground before burning up, it is called a what? A meteorite. So comets is an ice body that releases gas and dust when it gets closer to the sun. Comets are ice body that releases gas and dust when it gets closer to the sun. It is a body made of frozen gases and its bit its bit of rock. So comets what you need to know again, they enter the solar system and travel the comets, they enter the solar system and they travel around the sun, then leave the solar system again. Comets have three distinct parts, that is the head, an outer cycle of light called the coma, and the tail. So we have got the head, which is also two. We have also, thirdly, the tail, which can also be found when we talk about comets. It has got three main parts: the head, the coma, and the tail. So, when we, in other words, we should understand that these comets, they actually orbit around the sun at a greater distance and are found in the what? In the Kuiper belt and in the Oort cloud. They can also be found in the Oort cloud, which also comets that come into inner solar system do not live forever. When they come into the inner solar system, they do not live forever. The sun's heat melts the comets. So as you can see, we see that when it comes closer to the sun, we are saying that it actually, the comets, they release gas and dust when it gets closer to the sun. It means when they get closer to the sun, they release dust and gas. So what happens is that if they come into the inner solar system, they do not live forever, and then the sun actually melts them if they enter into the solar, in the inner solar system. So the head of the comet contains lumps of rock that are bound together by ice, and that are bound together by ice. And as the head approaches the sun, the ice melts and releases the gases and dust that we are talking about. The sun, as it approaches the sun, as the head approaches the sun, the ice melts, therefore gases and dust are released. I have got a diagram that is also illustrating that, which I want you to see right now, which shows, uh, which can also show that, which can also show what we are talking about. So, uh, when that happens, that will create a bright ring of what? Of dust and gas around the head, as well as very long bright light. As you can see here, we are saying this is the head, and then we have got also the tail that is being forming there. So what we are saying is that when the head approaches the sun, when it approaches the sun, it actually melts, and therefore those experiences are noticed. And then every time a comet passes the sun, it loses millions of tons of ice. It melts. This is the head. Sometimes you shall see that it has got a small hole there, or a small pointer there, and then as it passes the sun, it loses millions of tons of ice until eventually it is nothing more than a trail of what? Of dust, a trail of dust, which will be just saying that at the back there it will be just what? Dust that is also being released by it. So we have got our sun there. So as it gets closer to the sun, it actually melts, and therefore we are saying that, and therefore what happens is that it actually it has actually to release gas and dust. It actually has to release gas and dust. So uh, that is what we mean by this diagram. The solar, the shape of the solar system and gravity is our next subject that we want to look at. The solar system has a disc-like oval shape. The solar system has a disc-like oval shape due to the original planetary disk and the sun's immense gravity. We say that the sun has got its gravity, which keeps the planet in roughly circular and egg-shaped orbits. Egg-shaped, like to say the oval-shaped orbits that we see. So within this disk, large celestial bodies are spherical because gravity pulls their mass inwards. Uh, it is spherical. Reason of being spherical is because gravity pulls their mass inward from all directions, creating the most stable shape and sphere. It creates the most stable shape and sphere. So what we can see here is just a typical representation of the forces of gravity in their solar system, and then balance in a way that keeps balance in a way balance in a way that keeps the objects in their predictable positions. So you see, therefore, we have got the what? We have got our sun, and then we are saying we have got the forces of gravity in the solar system balancing uh the other objects in their predictable stable orbits. So as they are in their predictable stable orbits, this is also because of what? Because of uh the uh the gravitational force that we say it pulls the inward both from all directions that we talked about in there. So gravity is its natural force. When we look at gravity, its natural force that pulls other objects towards towards itself. When we look at gravity, so the planet and all other objects in the solar system are held in their orbits by gravity. Gravity is facilitating a planet and all other objects in the solar system to be in their orbits. So the more the mass an object has, the stronger its what? Its gravitational force. The more the mass, of an object has, the stronger its gravitational force. The stronger its gravitational force. That is one thing that we need to understand. The stronger its gravitational force. The stronger its gravitational force, and the closer two objects are, to each other, the stronger the gravitational force between them. When two objects are closer to each other, the stronger also the gravitational force that is between them. So of all the bodies in the solar system, the sun is the most mass. Of all the bodies in the solar system, the sun, it has the most mass and therefore has the strongest force of gravity. It has the strongest, it has got the strongest force of gravity, which is the reason why the planets and other objects in the solar system are revolving around the sun. They actually keep on rotating around the sun because it has got the strongest force of gravitational, or the strongest gravitational force. That is why you see the diagram that I just showed you here, which actually shows the objects that are rotating around the sun in there. It is showing the strength of gravitational force which the sun has, combining and forcing all other objects to rotate around it. So we want to look at the Kuiper belt and Oort, the Kuiper belt and Oort cloud. It is broad region between Mars and Jupiter, also containing millions of asteroids. We have seen it in the previous presentation there, which I was indicating the Kuiper belt, which also we said again that it also contains millions of asteroids. So Oort cloud is actually thought to be further away from the Kuiper belt and is thought to be consisting of lumps of dust and gases, are spherical in shape and surround the solar system. So the existence of the Oort cloud, where comets are thought to develop, was proposed by a Dutch astronomer, Jan Oort, in 1950. John Oort, 1950, actually identified the existence of the Oort cloud, where comets are coming from. And then the Oort cloud is a theoretical, this Oort cloud, the Oort cloud, the Oort cloud, it's a theoretical spherical region of ice bodies. It's a theoretical spherical region of ice bodies like comets at the far edge of the solar system, proposed by John Oort, 1950, to explain where long periods comets originate. He was identifying where comets are coming from. It's a vast shell of material located far beyond the Kuiper belt, acting as the boundary of the sun's gravitational influence and a home to billions of ice objects. So if you can look at this, we are saying it is actually uh, it's a vast shell of material located far beyond the Kuiper belt, far beyond the Kuiper belt. So do you see, I'm saying position this one, I can name it A, and also I can name it B. So position A, it's identifying the Kuiper belt, and also B is identifying the Oort cloud. So Oort cloud, according to Jane Oort, which we say that John Oort, 1950, is the one who identified it. We are supposed to understand that this Dutch astronomer, he actually identified that the Oort the Oort cloud is actually very far beyond the Kuiper belt, acting as the boundary of the sun's gravitational influence and the home of billions of ice objects. So ice objects are coming because these objects are farming are what are far from the sun. So therefore they can be able to develop from there. So the orange track represents the typical uh, cloud, and the Pluto's orbit is represented by the yellow. By the yellow, it is what the Pluto orbit. Pluto orbit is actually shown in there, which is actually identified by a yellow-like ring that you are seeing in this regard. So this is just a typical representation of how Kuiper belt and Oort cloud tend to be found with regards to uh, these what you call the objects surrounding the sun. So uh, the sun's gravitational influence and home to billions of ice cubes is actually thought to be the Oort cloud. So I want to appreciate your time and thank you very much for tuning in and connecting to Metric Hub. Don't forget to like, subscribe, and keep following such that we can be able to uh, get our distinctions. Metric will never be difficult. We're gonna do a comprehensive coverage of every piece of work that we're gonna meet and write on at each and every exam cycle, making us more than ready for final grade 12 examinations. Let us do it together right now. Keep connected, keep following. Thank you very much and have a beautiful stay. Thank you.